Okay, and our second speaker is Professor George Tchobanoglous from the University of California, Davis. And George is one of our Clark Prize laureates from 2003. He's also a member of the National Academy of Engineering and is awarded the Poland Medal from the American Academy of Environmental Engineers and Environmental Association of Environmental Engineering and Science Professors. That's too long. So George is famous for many things. He wrote some of the most important textbooks in our field, a big leader in decentralized systems, in constructed wetlands, and in reuse. And so today he's going to tell us about direct potable reuse. Please come up, George.
Building off the last presentation, I want to ask the following question. What would allow any of us to believe that any old treatment plant is suitable for producing potable water or high-quality water? And that's really one of the fundamental problems that we have in the field. So what I'd like to do today is I'd like to talk a little about the types of reuse that are accepted worldwide. Then we need to take another look about how we think about wastewater, and especially in light of the design of wastewater treatment plants, indirect and direct potable reuse, some treatment technologies, a little bit on the regulatory framework, and the need for a uniform vocabulary. So if we take a look at the types of uses worldwide, in order: agricultural, landscape, industrial, non-potable, recreational. Then we get indirect potable reuse through groundwater augmentation. Then we also have indirect potable reuse through surface water augmentation. And then finally, really direct potable reuse. So we're going to take a look at these, but let's talk a little about direct and indirect potable reuse. What are the driving forces for these two technologies? Well, you heard it before, but certainly the value of water is going to increase dramatically. In the Central Valley in California, it's gone up by a factor of 3 in the last 5 years, and I anticipate it will go up another factor of 3. De facto indirect potable reuse is a reality. Infrastructure limitations. The technology is really not much of an issue, but population and global warming are other issues that will drive potable reuse, not only in this country, but throughout the world. Now, with de facto indirect potable reuse, I always use this diagram because it's the Colorado River. There are 456 discharge permits on the Colorado River. 256 are active. And so when you're in San Diego, I've always said it before, you drink the water and you get a nice warm feeling. Because you've just bonded, you've made friends, people you didn't know. But if that bothers you, what you have to do is go up to ski at Utah. 2 weeks later, you come down and sail in San Diego, and you bond with yourself. So when you look at these rivers across the if you look at Houston and Dallas, and consider that at times 3/4 of the flow in the river is barely secondary treated wastewater, which is pumped out and used as drinking water, it often defies logic why we're so concerned about all these things. Now, I showed you this picture of Hyperion. I want to use the picture of Hyperion for another reason. Mike Stenstrom did a study and looked at the energy it would take to pump the water from here to North Hollywood. And it takes more energy to pump it to North Hollywood than to treat it at Hyperion. And as you start to think about these things, that's going to be a bit of a non-starter as we move along. The next issue that we have is that by 2030, it's estimated that 60% of the world's population will live near a coastal region. Now here's the issue. As the population increases in general and we need food supply, it's hard to imagine taking water from centralized areas, bringing it to the coast, using it once, and dumping it. It's unsustainable. And we could talk about that at greater length, but I just offer that up, that as we get these population shifts and our population increases, what we're doing is really unsustainable. Now, in the 21st century, we need to think about wastewater differently. Wastewater is a renewable, recoverable source of energy, nutrients, and potable water. That's how we have to think about it. The reason that becomes important is that when you start thinking about wastewater that way, you think about different types of designs. You know, when this is not a talk on treatment plant design, but there's so many things we can change in the way we do treatment. But we need to think about, as we start to make these changes, we need to think about it in terms of, this is a resource. We're going to get nutrients, we're going to get energy, and you heard that before in the previous talks, but more importantly, we're going to produce potable water. Now, if we talk about definition of indirect, on the bottom line we have advanced treatment, and the line going up is essentially the indirect part with surface water augmentation and groundwater recharge. When I talk about direct potable reuse, I'm talking about the bottom line in which we go from advanced treatment to an engineered storage buffer, and from there either into an intake of a water treatment plant or directly into the distribution system. In time, I think we'll be able to eliminate the engineered buffer and go directly from treatment into the system. What are some examples? And what we're talking about here is the Orange County Water District essentially is the treatment with injection. San Diego, which just received its permit from the health department to add water to the San Vicente Reservoir, will add surface water. Now, as you think about adding water to, let's say, a surface water reservoir, just imagine what would happen if that reservoir just shrank down to nothing. And that may be the direction we're going. Now, types of projects. Here are typical infiltration basins in Florida. These things are amazing. They pump water into them, and they have never gotten water to spread all the way out to the edges. It just runs at enormous rates. Here's a typical, these are some of the examples of they're spread throughout the central part of Florida, and an amazing amount of water is recharged. And with the new limitations on discharge in Florida, even more so will occur in the future. Now here's the spreading basins Orange County Water District. I don't want to linger on these, but I want to bring up one point. Orange County Water District basically beats the water with a stick and then puts it out in that surface water reservoir. And at that surface water reservoir are geese. Have any of you ever seen geese poop? I mean, it's like the kids' pencils you used to get, you know, those big ones? Now, there's another issue here. Down below is the Santa Ana River. Now, here's what's interesting. In the Santa Ana River, you can recharge that water regardless of any of the contaminants that it might contain, surface runoff, partially treated secondary, without any regulation at all. Why? Because it's waters of the state of California, and the regulations don't apply. And so there are these disconnects as we move ahead. Barrier injection wells, that's been talked about, typical examples here. Now, this is surface water augmentation. This is the San Diego. You notice the spaghetti, purple spaghetti. In my judgment, in the long run, the use of purple pipe will not serve us well. And the reason that it doesn't serve us well is that the public believes somehow that we believe the quality of water is not acceptable. And with the treatment technologies that are moving ahead, we shouldn't have that. Also, that spaghetti only allows about 2 million gallons per day of recycling. If you're really going to do significant amounts of recycling, you've got to have either an environmental buffer or, as we talked, direct potable reuse. Here's the reservoir, San Vicente, and studies have been done that you could imagine this eventually all becoming recycled water, purified water. So at this point, what's the issue? The issue is if we're going to recycle significant amounts of water and cities don't have either an environmental buffer, either groundwater or surface water storage, then direct potable reuse is the answer. Now, what's interesting about direct potable reuse is another benefit. 20 parts per trillion of, let's say, an endocrine disruptor might be the treatment levels we could achieve. If we discharge that, 20 parts per trillion have been known to cause sex reversal in fish. Now, my department chair, who's a woman, says, a little less masculinization is okay. On the other hand, if we were to drink this water with 20 parts per trillion, we would have to drink 496,000 8-ounce glasses of water to get what a woman gets in a single birth control pill. So, as you think about this, if you're really an environmentalist, it's far better to drink this water and save the environment. I don't notice much enthusiasm. So now we're talking about, here we're talking about direct potable reuse with or without an environmental buffer. Now, when we look at environmental buffers, they could be of any type. Surface water storage, groundwater. Only your imagination limits you in terms of the design of the engineered storage buffer. When we talk about trends in treatment technology, the bar has been set pretty high by the Orange County Water District. Here's their diagram. I'm not going to go through this. You're all familiar with all the various processes. But microfiltration, cartridge filters, reverse osmosis, advanced oxidation. It's interesting. People say, well, why cartridge filters if you have submerged microfiltration? And the reason for that, of course, is that the chemicals used to prevent scale are not highly purified. And so to remove the impurities from those chemicals, you need cartridge filtration. Here are the units. And one of the things that truly is exciting at the work that they're doing, you notice this upper module? What they have done is for each bank, they have an additional module in which they're testing new membranes on a continuing basis. And what that allows them to do is to really benchmark the performance of new technologies versus what's going on currently with their existing process, and you're doing it at full scale. Now, here is the diagram for Big Springs, Texas, and essentially they've adopted the Orange County Water District scheme. They're going to take their water, they're going to blend it, and then it's going to go through a water treatment plant, and that will be direct potable reuse. Now, Big Springs, Texas is a bit of a problem because their water supply has a TDS of 3,000. If you drink that water and you have fillings, you can tune Wichita in your mouth. This is the flow diagram for Namibia, South Africa. Windhoek, Namibia, sorry. It used to be part of South Africa. But you'll notice that in their bottom diagram, which is the more recent one, they do not have reverse osmosis or advanced oxidation. Their process relies on ozonation and biologically activated carbon and a variety of other new technologies. I just need to tell you one story about this. When this system first went on, this was 30 years ago, they announced to the public when it was going to be turned on. That Monday, people called up and they said, you know, my right arm fell off. I've lost my tooth. Everything imaginable. Fact of the matter is they didn't turn it on until 3 months later. So public perception really is a major issue here. Now, as we start to think about this, inland areas where we don't have access to an ocean for brine disposal, there is certainly a huge interest in the many different ways we can use ozone effectively for processing the trace organics in wastewater. What's happening here? Jimmy, do you have any?
Try that one. No, you were right the first time. Uh-oh.
Page down.
Nothing is happening. It's frozen.
Nothing is happening.
Now this is moving here.
We have all the experts here.
No, just us.
Oh.
Maybe try escape. Start over.
Yeah, press the escape.
Even escape doesn't work. Oh my.
You want to reload it?
No.
Let me try this one.
Okay.
I didn't.
Yeah.
It's frozen. Oh.
Oh, got it.
What did he do?
whatever. It was wonderful. The long and the short of this particular table is look at the bottom line. If you look at the energy consumption for the ozone-based systems, you're talking about 0.03 to 1 kilowatt hour per cubic meter. With RO, UV, you're talking about 8 to 10. So it's a huge difference. Now, when we start thinking about designing these new treatment plants, there is a whole new technological implementation scheme that we have to look at. Just as an example, it was mentioned in the previous talk that why do we return flows from, let's say, digester supernatant or dewatering activities to the head end of a treatment plant during the daytime hours? Why? Because the operators are there. And yet it screws up treatment plant performance, something fierce. So as a minimum, if you just put in flow equalization, you would enhance the performance of your treatment facility. So we really need to rethink the way we design these treatment plants from the get-go, and especially as we think about producing potable water. Now, I couldn't come to Southern California without giving you my solution. All right, here's what happens. You've seen this diagram with the transport of water to the Los Angeles area, but what I'd like to have you focus on is on the left-hand side, and look at that elevation rise, 4,000 feet that we have to pump that water over. Right now, the pumping costs for water in California amount to about 20% of the total energy usage in the state. And as you think about taking that water and pumping it back for agricultural reuse, it's a non-starter. Let's take a look at what happens here. If we look at treatment, distribution, and wastewater treatment, they're the same. But look at supply and conveyance. Northern California, 150 kilowatt hours per million gallons versus 8,900. That's gives you some idea of the magnitude of power that's now consumed by transporting water over the Tehachapi's. So, what's the answer? Well, the answer is that we should reuse water in Southern California. And what would that do? Well, it would add additional water for agricultural use during dry periods or drought periods. It would add additional water for environmental benefits in the Bay Delta system. How might we do it? Well, we already have distributed wastewater treatment facilities. We would just simply put, for the sake of discussion, an Orange County Water District type treatment plant at each of those locations. Well, what does that mean? Right now, we're talking about $30 billion to build peripheral tunnels around the Bay Delta. It works out that you can put in 1 billion gallons worth of treatment for $5 billion. And so you now have to think about it a little bit. It's not as simple as just, let's put in tunnels and do more of the same. There are alternatives here that are significantly less expensive and make a lot more sense. And we have more water for agriculture because our population is going to increase. We have environmental benefits. We have reliable supplies. So it works out that the $5 billion is a high estimate. I think it could be done for less. But that's the scale that we're talking about. Now, on regulatory requirements, the only thing I'd like to talk about is that in the post-1980s, science really has leapt ahead. I mean, it's just outstripped us. And unfortunately, we still have semi-empirical and empirical legacy regulations. Now, for example, in the Orange County Water District, when the state issued its standards, it said you need 6 months in the groundwater. So I said, well, where does this 6 months come from? And the answer is, well, we think you get 1 log of removal for each month in the groundwater. And I said, where in the hell did that come from? Sucked out of the air. So that one went away. Then they came back the next time and they said, well, you know, we think it's dissolution. Dissolution. Well, the long and the short of it, as you all know, that requirement has now been reduced to 2 months, and it has nothing to do with viral inactivation. And so it's this disconnect between science. When you think about Title 22, it's based on the regulations that we developed in 1968 when wastewater treatment was terrible, just simply terrible. And we hung a complete water treatment plant on the end of it. That's the time period that our regulations date back to. They've really not been updated. And you all need to we need to work on that. The last thing I'd like to say is we need uniform terminology when we discuss these issues. And the issues are we need to speak with one voice. And again, not everyone agrees that indirect or direct potable reuse is acceptable, but there's little standardization of terms. What's the consequence? Literally everyone says whatever suits their purpose. And it's all just chaotic. The public is confused about the safety of reclaimed water. We call it so many different things. Now let me give you an example. When you buy Dasani and you look at the bottle and it says purified, how many of you have asked if this was crap yesterday? You're pretty content. It says purified on the label. I mean, that's got to be it. That's it. So, clearly the public is confused. And finally, we really do need a uniform vocabulary if reuse projects are to be discussed rationally. We all need to be speaking with one voice. We don't have to agree, but we ought to agree on the terminology. And the take-home message, at least from my perspective, is I think ultimately direct and indirect potable reuse is inevitable in urban areas and is going to represent an element of sustained water, essential element of sustained water resources development. So what does that mean for us? It means, number one, we need to think about wastewater differently. Number two, to make it a reality, we need bold new planning. And part of that is to combine water and wastewater agencies into water agencies so that they work together for the betterment of society as a whole. And the next issue is that when explained properly, the public is supportive. The public is supportive, and that's the most important critical issue. In study after study, it depends on how you ask the question. If you come up to someone and say, "Are you willing to drink crap?" and say, oh, I'd have to think about this. On the other hand, if you show them the Colorado River system and you show them the purity of the water that you can produce, acceptance is like 80%. Now look, you're going to have 20% that will oppose anything. You're never going in our society, we're never going to get 100%. But the idea is, if explained properly, the public is supportive. And with that, I'd like to thank you for listening.